This is the Math School Championships 8th grade 2009-2010 problem number 39. Before the video begins, make sure you have a solid understanding of combinatorics. But even if you don't, that's okay. Keep watching the video and let me know down in the comments if you want a video explaining anything. So, on Saturday afternoon, 6 friends play doubles tennis. Partners change after every game such that during any given game, 2 players sit out and no 2 games involve the same 4 people paired against each other the same way. For example, for the set of 4 players Arthur, Beth, Charlie, and Denise, there are 3 possible pairings. Arthur and Beth versus Charlie and Denise, Arthur and Charlie versus Beth and Denise, and Arthur and Denise versus Beth and Charlie. What is the maximum number of games that can be played under these conditions? Alright, so let's first try and, find the number of ways to choose the first team. So if we want to find the number of ways to choose the first team, there are 2 people on the first team, as you can see here, and there are a total of 6 people. So, we want to choose 2 people from 6 people. That's just 6 choose 2. So we have our first team chosen. So let's try choosing our second team right here. Now you may think that it's 6 choose 2, but remember, we've already chosen 2 people to be in the first team. And according to the problem, those 2 people can't also be in the second team. So in reality, we only have 4 people to choose from. If you didn't understand that, think about it. 6 choose 2 is counting the number of ways to choose 2 people from 6 people. What we want is to choose 2 people from 4 people because we've already used up 2 people. So the number of ways to choose a second team is 4 choose 2. So we would multiply here, 4 choose 2. Now again, this may seem like we're done, but there's something we have to think about. Let's try and visualize this. Let's say we chose our first team, and we chose in the team person A and person B. So in our team 1, we have person A and we have person B. And in team 2, we have person C and person D. Now, let's think about what would happen if we instead chose person C and person D first, and person A and person D second. So we would have, C and D on team 1, and A and B on team 2. Well, obviously, we want these 2 to be the same, because if person A and person B go against person C and person D, that's the same thing as person C and person D going up against person A and person B. So we want these 2 to be the same. But the way we're counting it, they're not. They're different. Because we're choosing 2 people out of 6 people here. We could choose A and B, or we could choose C and D first. And then for this 4 choose 2, we could choose C and D or A and B. So that's clearly a problem. So what can we do? Well, obviously we want there to be one way to choose a team 1 and a team 2, like so. So right now, there are 2 ways for team 1 to go up against team 2, for team 1 to versus team 2. But we only actually want one way. So how do we get this one way? Well, the answer is simple. We divide by 2. So we've got to divide by 2 here. And now it's time to calculate our answer. Well, 6 choose 2 times 4 choose 2. Let's just rewrite that. 6 choose 2 times 4 choose 2 over 2. Well, 6 choose 2, that's just 6 times 5 over 2 times 1, which is 30 over 2, which is 15. So we have 15 here. Times, 4 choose 2 is just 4 times 3 over 2 times 1, which is 12 over 2, or 6. and then divided by 2, and we can cancel these, and we get 45. And 45 is our answer. So this is a great example of a combinatorial problem, or a combinatorics problem. So let's try another combinatorics problem. So the problem asks, in a parking lot, 100 one-year-old cars are parked. Out of them, 5 are chosen at random for a pollution device check. How many different set of 5 cars can be chosen? Well, we have that there's a parking lot with 100 cars. So we have 100 cars. So I'm obviously not going to draw all these cars out, but I'll just draw car 1, and then we have car 2, and then we have dot 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 car 100, right? And we want to choose, well, 5 of them, right? We want 5 different cars to be chosen. So this question is very simply then reduced to a combinatorial problem. 100 choose 5. We want to calculate 100 choose 5. So let's do that on the next page. So let's just write down 100 choose 5 here. 100 choose 5. And now calculating this is totally optional. And if you did want to calculate this, it would be pretty tough, but let's just go over the steps of how to calculate it. So 100 choose 5 is 100 times 99 times 98 times 97 times 96, all of that over 5 times 4 times 3 times 2 times 1. Now, if you did go through the hassle of actually trying to solve this, you would end up with 75,287,520. Alright, so now that we've finished this problem, I have got one last challenge problem for you. So let's see if you guys can solve that out by yourselves. This is Amy number 1, the 2020 problem number 7. And here's the problem. A club consisting of 11 men and 12 women needs to choose a committee from among its members so that the number of women on the committee is one more than the number of men on the committee. The committee could have as few as 1 member or as many as 23 members. Let n be the number of such committees that can be formed. Find the sum of the prime numbers that divide n. And you can always, you don't have to do this. This is just part of the Amy problem. If you want, you can just give your answer in a n choose k format. And that would also be fine. So why don't you guys try this problem out by yourselves? And stay tuned for the next video where I'll be solving this problem. So thank you all so much for watching. Please don't forget to like and subscribe, and I will catch you all in another video.